So again, welcome to FayettePy. And so over the last 5 years, I've been here in Northwest Arkansas, and my wife was just, she moved to Nevada, and then she missed everyone so much that we came back. And I can see why, because y'all out here in Northwest Arkansas have some sort of like southern charm or something. Yeah, it's really hard to describe if you're from other areas. So when I came back here, I was very interested in what I could do to grow myself, how I could become better. So I tried to find time to come to either this one or the other. I think we have 4 other development type meetups here in the community. And then last year, one of the things that I wanted to do, I wanted to take a course from the U of A Global Campus. At U of A Global Campus, they have a lot of certificate courses, and a lot of them really didn't fit with my schedule, but then I saw one on data science. So I was like, yeah, I need to do that. And I see Ty, he was in the class with me. It was like 8 weeks of, I just couldn't get an idea of where we were going, because it wasn't like the traditional college course that I took when I was getting my computer science. One of the things that we had to do was a project, and then they would like give us like pieces of information, and we were trying to figure out how it related to what we understood. And so it was always like quicksand. You know, we were like, we'd get into one topic, and then there would be another thing that was thrown at us. And I didn't feel like I had a good understanding of it, but when I got done, magically, things just started to fall into place. And one of the things that our teacher required of us is to do a project. And so, you know, she mentioned that if we needed pointers, she'd give us some help. And so she mentioned to me, one of the great things to do is image classification or image recognition. And at the time, I was like, given all this time, I don't see how this is going to work. And so then I went back to something that I knew, because I work in the banking industry. I did a presentation on a big chunk of data to see if I could understand if we can decide if a bank is going to acquire another bank or not. So I was just looking at the data to see if we can create some insight. And so one of the things that my teacher said to me was, oh, TensorFlow, it is the nectar from the gods. I'm like, what? Nectar from the gods? And so when we got out of the course, you know, you relax, you get a chance to debrief and let things just kind of sit where they lay. I thought, well, let me go ahead and see if she was right. And then the other thing that popped into my head, well, why don't you go see if you can figure something out with TensorFlow being specifically with image recognition. How do you take TensorFlow and can you like build some sort of model so that you could leverage it somehow? You know, that's the thing that I was trying to figure out. How can you actually use this TensorFlow that's this nectar from the gods and turn it into something that's useful to you and me? So I'm like, okay. And I went on this journey trying to figure out how easy it is to manipulate, to use. Before I get started, I found this really cool video to talk about data science. So I'd like to share that with y'all. Chrissy, do you know how I'm supposed to like share
That I do.
through?
I think usually it comes through the TV that you're playing on.
Okay, so we'll have to me start this over again.
I don't know if that's gonna work, 'cause I didn't hear anything.
Yeah, I'm not hearing anything either.
Do you know, Austin?
You can, in the finish, you should be able to have it come through your computer speakers instead.
Mm-hmm.
I think up there again, at the icon where you play it through the Apple TV. So this one up here. Which one? This one? No, I think I'm incorrect.
Yeah, go to your system settings.
And sound?
Yeah, and then make sure that your output is your laptop.
Mm,
Go to output.
output, okay. And internal speakers. So let's see if they can get this to work.
Data science is a process, not an event. It is the process of using data to understand different things, to understand the world.
For me, is when you have a model or a hypothesis of a problem and you try to validate that hypothesis or model with your data.
Data science is the art of uncovering the insights and trends that are hiding behind data.
It's when you translate data into a story. So you use storytelling to generate insights. And with these insights, you can make strategic choices for a company or an institution.
Data science is a field about processes and systems to extract data from various forms, whether it is an unstructured or structured form.
Data science is the study of data, like biological sciences or the study of biology, physical sciences. It's the study of physical reactions. Data is real, data has real properties, and we need to study them if we're going to work on them.
Data science involves data and some science. The definition or the name came up in the 80s and 90s when some professors were looking into the statistics curriculum, and they thought it would be better to call it data science. But what is data science? I see data science as one's attempt to work with data to find answers to questions that they are exploring. In a nutshell, it's more about data than it is about science. If you have data and you have curiosity and you're working with data and you're manipulating it, you're exploring it, the very exercise of going through, analyzing data, trying to get some answers from it is data science. Data science is relevant today because we have tons of data available. We used to worry about lack of data, now we have a data deluge. In the past we didn't have algorithms, now we have algorithms. In the past the software was expensive, now it's open source and free. In the past we couldn't store large amounts of data, now for a fraction of a cost we can have gazillions of data sets for very low cost. So the tools to work with data, the very availability of data, and the ability to store and analyze data, it's all cheap, it's all available, it's all ubiquitous, it's here. There's never been a better time to be a data scientist.
One of the things that I thought when that professor was talking that was rather insightful, it's that data science is one's attempt to work with the data to find answers to the questions that you're exploring. And you know, when he was breaking data science down as like this exploration, the other thing that I liked what he mentioned, and I kind of characterize it as like a mindset of being curious and discovering answers from that data that you have. The other thing that is particular to what we're talking about tonight is where he emphasized that the data science tools are accessible and cheap. The tool that we're talking about is free, so you can't get any cheaper than that. The only downside of a free tool is that you get to learn on your own. So, you know, it's like, how much time do you have? You can spend it to figure anything out. So I guess the thing that it made me think of is when I would listen to this video, I wanted to kind of compare what they were talking about in data science versus what traditional programming is. And I found this Medium article that had a nice little way of, putting a Venn diagram on this piece of paper, how data science is this crossroad between the business and machine learning statistics and computer science. And when I went to school for computer science, to become a programmer, you really were in one track of computer science. Things that I remember we discussed was those algorithms, and I took a compiler construction class, and it's on ideas on how to build a robust system. And when I was looking at this in that class that I took that I mentioned to you all, I guess I started thinking of data science as, you can decide both the programming and the data science in some sort of maze. If you look at the approach, where you're going, the mindset that you're having, the person that's a traditional programmer, you sit down with whoever your SME or your subject matter expert is, and they talk about how they do the job and what data points that they're trying to collect. And you're like working your way down to figure out how it relates to the data. And in that course that I took, it was more of, well, let's start at the end and work our way back up. Let's only look at the data that we have. How does that relate to something that we could discover, some sort of insight? And that's one of the things that I remember my teacher kept talking about. What's the insight that you're bringing to the table? And one of the deliverables that she showed us was a flowchart. And, when I sat there, I'm sitting there like, well, how can somebody in data science make over $100,000 a year just to produce one little flowchart? That was at the beginning. And through the course, that flowchart becomes very important. If you're on the floor trying to make a decision quickly, and you just look at this flowchart and you can make a decision in a split second, now you don't have to waste all this time of trying to figure out how to do your job. It's explained in one little document, and that document is probably worth a couple $1 million. Yeah. And it blew my mind. How in the world can this document be so valuable? Because from the last 20 years of me being in the industry, what's valuable is something hard, something like you push a button and it's cool. And if it's not cool, then you don't feel like you've done your job right, And it bugged me when I was in this class. But over time, it made me start realizing, when you go back to this little Venn diagram, you're also dealing with business knowledge. You're dealing with a business person. They don't care how you get the job done. It just needs to be quick and under budget and on time, There's a lot of stuff that it started to make sense. Doing the job is a lot different than having the coolest technology out here. So, of course, maybe this is a good time for us to discuss some of the terms that we discussed in this data science course. And we were talking about machine learning. And if you look here, machine learning is this application of artificial intelligence that provides systems' ability to automatically learn and improve the experience without being explicitly programmed. There's a lot of information in there. And I guess the thing that kind of stood out from all of this description of what machine learning is that artificial intelligence. And I remember being a little kid, the first time that I watched this 2001 Space Odyssey, and we had Hal. It seemed like Hal was evil. And, it was like some bad thing to have some sort of artificial intelligence because it was going to rule the world. And then I also remember watching Terminator, maybe too soon. You know, my mother cautioned me from watching that. It gave me nightmares, to think that these machines had bad intent and they were going to destroy the whole world. But I guess the thing that when I went through this data science course, machine learning is focusing on the development of the computer programs so that it can access the data and learn from it and have the program learn from it. Because I remember different models that we could just work with, one being supervised, where you had somebody trying to figure out what are those common things that would make one thing a platypus versus a bird. You know, platypus, they have a nose, and the birds have, or that beak, and the birds have it, but one's cold-blooded and one's warm-blooded. So I remember that when you were trying to like categorize what it meant to be one thing or another, you need to figure out how many different categories and the least amount of them so that you could make let the computer make a decision between one and another. So this guy does a really good job describing the 7 steps of machine learning. Gathering your data, preparing your data, choosing the model, training it, the evaluation, the hypertuning, and the prediction. We're not going to watch this YouTube video, but I'm going to provide the slides to Chrissy, and then if you guys are interested in this, you're welcome to come back and watch it on your own time. So, you know, we talked about artificial intelligence, machine learning, and then there's this other thing called deep learning that we're going to work with. And I wanted to kind of find a quick way of describing how do you scope each one. And with this picture that I found on the internet, the AI, it's very simple description. It's machines doing tasks required for human intelligence. And then machine learning is the computer's ability to learn without being explicitly programmed. And then this deep learning is just another technique that's a machine learning technique that makes the machine learn using a neural network. So every time we were digging into these concepts back in the class that I took, you know, it's like the vocabulary, you needed to figure out where it all fit. Well, when we talk about the deep learning, and this is a good description, and this is the link if you want to go back and read it. It's talking about how, and the way that it made sense to me is that some of these pieces of where we were talking about that feature extraction, what are those characteristics that makes a bird versus a platypus? You know, what are those minimum amount of characteristics, and they're calling them features. Could you determine to figure out which is one or the other? And we're allowing the computer to do it. Well, machine learning, sometimes you need to have somebody involved in trying to make those classifications. With the deep learning, you're letting the computer do it. And in this example, when you're putting some sort of input in there, and all we're trying to decide in this example is whatever you put into this black box, if you would, it's going to either give you a car or not a car. It's just like this red light, on, off. It's just a way to make a quick decision. And as we read up above, that deep learning relies on a neural network. Well, here's the definition of neural network. It's a computer system modeled after the brain and the nervous system. And if you remember basic biology from high school, and man, this is over 20 years ago, it's crazy how we get a message from our finger all the way to our brain. And it's by passing information to a whole bunch of neurons. And this is just a quick example to show you that if you were to have a layer or a whole bunch of ways of deciding one or another, you could have something where you have something that you start with means something totally different. And this video right here talks about how they're using neural networks to recognize numbers. It's a 20-minute video, and so I'm going to let you guys look at that if you want to on your own. So for this to work, when we start using TensorFlow, we really want to leverage this technique right here, transfer learning. And the whole big idea when it comes to transfer learning is that you already get something that's like a model that's already trained to make decisions, and you're just tacking on one of your little layer so that when it's all said and done, it's faster. You don't have to train on a whole bunch of images, and you can get this thing to pop out, whatever that is, and we'll talk more about that later. So the models that you can use, and here's a couple that you can use for image recognition, and this is in Keras. The one that we're actually going to use is MobileNet. I've seen some other videos talking about why you want to use Inception v3. I don't really know of any of the other ones. And, you know, this is something that if you guys want to research it on your own, that could be, we could just spend the whole time on talking about one of these models, and you're welcome to present anybody that wants to do that. So in the image recognition, one of the things, since we're using this deep learning, we're letting the computer create these layers or ways of recognizing it. This slide right here helped me understand what it's actually doing when you've got these bigger models. And the first layer, it's just trying to make sure it's taking the pixels and putting them together to figure out what your edges and your shapes are. Then when you get those edges and shapes down, you could start building out certain characteristics that are on a face, like your eye, your nose, your mouth. And then the third layer is actually giving it more character or more information. So this is a guy's face. And when we use transfer learning, we could actually make another layer to make it me and everybody else. Yeah. That's just an example that you could do if you were wanting to use this technology for that. So one of the cool things with deep learning, I found this example online that I wanted to share with you all. And it's talktotransformers.com. You can put whatever custom prompt you want in there. And when you push generate, it starts building out a nice paragraph for you. So I wanted to show you what it would look like if we were to use this to do the talk that I am presenting to you all tonight. So let's put in the title. And then a few seconds later, or a couple of minutes, it's starting to create something here. I guess it's giving us some sort of code. And then it's like a start to this. Well, if we wanted to change our talk to maybe something else, like machine learning is, it's already starting to write the notes that I need for the presentation. I don't know if it's something that you guys would want to hear, but it's machine learning is based on the formalizing the behavior of components in terms of abstract elements that are easy to understand and manipulate. Simple reinforcement structures are implemented to, and you can just keep going. The thing that's crazy about this website is that I could keep on hitting that generate another, and it would start writing another couple of paragraphs. And the reason why they have this website, just want to point out, it's they wanted you to buy their GPU cloud for deep learning, so they're trying to sell you some hardware. So if you're interested, you just come on to this website. So now, here at Codelabs, Google, they're very generous with their knowledge because they try to help people advance their understanding. And so here, I'm just going to click on this here, and I'll show you all what they have. If you were ever interested, they've got different things that they can teach you. So you can do some sort of, use this AR core, and they've got a lot of courses here that they just give away for free. The one course that I'm interested in is this one right here. When I originally started this back last quarter, it was called TensorFlow for Poets, and then they went from TensorFlow for Poets. Now they went to TensorFlow for Poets 2, and then you gotta love Google. They scrapped it, and they went. Now they're trying to show you the course on how you can take this TensorFlow light model, and the way that what they've done is they've trained this model on 5 flowers to put it into I guess an Android application. So after you build your model, you can do the same thing that they're doing if you want to go through the same course. Well, building the model, they give it away for you free in this Codelabs example. And it looks like it's just like a Python or Jupyter notebook. So if you look here, the first step, of course, is to bring in all your libraries. And after you bring in your libraries, of course, you want to make sure you're on the latest and greatest version. So they have a check here for that. And when I was running through this example, it's crazy how all this stuff, you don't even need to download it to your local machine. We've got here all of our images, and what they've got is 5 different directories of images. And we'll go back and I'll show you what's in this folder, because I've downloaded it to my hard drive. After that, they take the images from all these different sizes and they make it smaller, and then they break them up into 2 different categories. So they've got a trained model here, or trained and then they have a validator, and I think they're splitting it up. 80% is in the trained model, and then 20% is in the validating category. And then right here, they're going through all of your image, or they're creating the batches, the shapes, or the data. They're looking at the data. And then this piece right here is where they're creating this label text. And this is what the first category is: daisies, the second one is dandelions, the third one is the roses, and so forth. It's a zero-based or zero-indexed array. And then this is what would be in that label file. And we'll look at this example in a little bit. And then here is where they start using that MobileNet. I guess it's version 2 is the model that they're pre-training. And so this is where that transfer of learning is taking place. They're taking all these images that we've got, and it's a small subset. I mean, in each one of these directories, we've got 700 images of each one of the different flowers that we have. And here, they're getting things ready for us to use. They're now using the feature extraction. So this is where the machine is doing or training the model for us. And it's adding in each one of these layers for us. There's a convolutional layer so that it sees the images and the shapes. I think I put that one. And then down here, we're compiling the model. We've got a summary of the model, and you can see the different layers that we have. And then different parameters. Some of those parameters are huge. And this is where we're training the model. And this one, they're going through, running the information through that model 10 times. And this is going to take a little bit of time for it to run through that. So I think it's a good time for us to go look at what actually is in the folder that they had, that they're training their model on. And if you look here, there are the images of the dandelions. Or this is the daisies, I guess. You can see that up there. If we were to change the names of these folders, then that in the folder, or whatever we make that folder's name, that's what's going to pop up in that image or the labels.txt file. So if we want, one of the things that I'm working on right now is I'm trying to figure out how to associate, like, as an example, I would take dandelions and I'd call it the yellow flowers of doom or something, you know, if you've got allergies or something like that. To give each one of these images a different meaning. And if you look, they've got so many different images of roses. And the one thing that they mentioned is to help TensorFlow make a really good shot at figuring out if it's a daisy or not a daisy or a rose or any of those things, you really want to get the images to be in so many different random pictures so that it can decide what is a rose or what is that feature extraction. Because it's the machine that's figuring all that information out. It's trying to figure out what areas or what types of shapes that these images make a rose a rose. And you can also see that there's a whole bunch of images here for the sunflowers, and I think the last one's is tulips. Let's go ahead and look to see where things are. So it's gone through the epochs, so it's trained the model, and then now we're analyzing to make sure things look good. So if I take an image and I throw it into this model, it can predict one of those images. And then it's now doing this freezing top layer. And then it also does one more compilation of the model down here. So we have, after it gets started, see down here, we're almost to spitting out this TensorFlow Lite file that we can use in a lot of different places. And I have an example on how we can use it. So let me hit this summary. And we need to do one last training. This is going to only be 5 epochs, so it's just going to run through that 5 times. And during this training, I'm going to show you, I've got a mobile version of this where I've taken these models and I've got it hooked to a camera, and after we create our model and upload to my computer, I'll show you how it works, or give you a real-time example. So this is, in this first one, it's got kites, hens, ostriches. You've got a lot of birds in this example. So it's trained on this. Let's see, which one is this one? For the MobileNet version 1, there's a lot of different labels that it's trained on. And then for this YOLO one, I think it's a lot smaller. But you see, you can look at a sandwich, an apple, broccoli, hot dog.
So it should be able to identify those items pretty reliably already.
Yeah, when you hook it to something. So some of the research that I was doing, you can hook it to like a Raspberry Pi, or what was that thing that you brought, Chrissy, last time?
CircuitPython.
Yeah. You hook a camera to it, like a cheap camera, and it starts, I remember seeing one video where there was a person, it creates this box around it. You know, of course, you got to leverage the code to create that box, but when it gets into a certain, it tells you that it's like 40% a chair or something, you know. So let's just finish this off. I think we're done with the 5 epochs here. And now we're converting and saving this TensorFlow Lite model. Or it's doing its thing there. I guess right here is where we're going to actually download the model. And we can put it on our machine here. And of course, it tells you that some things are no longer, are like warning, some of this stuff, it's going to be out of date soon or something. So we're done with that one. Here, we'll run it through its paces, and as it's doing that, I'll show you the actual app that I built. Oops. So it's downloading that for us. Let's see if it can do this. Okay, I'm mirroring my phone. Here is the app that I've built. And so this first one is the SDNet model. So it's saying that that's a chair. You also see that it says airplane there. So somehow Casey has put an airplane in here. And then, see, now we got a person and a skateboard. I don't know where that came from. We've got like a refrigerator here and a TV. But as you can see that if you want a better model, you just have to provide more images. And that's the thing that blows my mind, is that we're no longer deciding, like typing on a computer that says, this is what I think a refrigerator looks like. And we're letting the computer do it all. I'll show you one other one that I think is really cool. This one right here, it's a little different. It puts dots on people. And if, man, here, can you put it on me? And see, there I am, right shoulder, right elbow, left elbow. Yeah, in real time. So after you get your model trained, now you figure out how to, put it on a device. There's my wife. And I think it downloaded it to my machine. So let me go back to the presentation. There's my little demo that I just showed you all. And now I guess open it up for question and answers.
So that TensorLite file, what was the process of getting that into a mobile app?
I just found an example, and it's in I use Flutter, and it's leveraging code base that are like an add-on to Flutter. It's called TensorFlow, and it's just linking a file to the camera. So I mean, it takes a little bit of work to get it to work, but once you get it to work, I just stopped after I got it to work, because it's like, wow, this is super cool. Look at what you can leverage. And then when Chrissy mentioned that there was an opportunity to speak, I was like, sure, let me talk about this.
Kind of basic question, but what exactly is an epoch?
I think it's on when it's training. It's like the iterations. There's some sort of like statistics when it takes all the images that it has, and then it says, we're going to take a subset of those images, and now let's train on that to see if we can get some sort of idea what the difference between a lily, dandelion, or whatever. In our simple case, there's only 5. But you could have a whole bunch of images, and so then it takes a lot longer to train your model. So, I think what I saw when I went to, there was a data science meetup up in Bentonville. The guy that was talking on that, he had changed the epoch. Like if you made it 20, it made it a little better so that it recognizes things a lot better. So as you saw, we had a refrigerator over here. I think one of the ways to get rid of that anomaly would you just have to keep training it more and more.
Because because it's deep learning, it doesn't only have feedback from whether or not its prediction based on the data was correct, but also if it was looking at the right parts of the data to make that decision. So I guess maybe an epoch has to do with part of that, some iteration of that feedback loop.
I think that's what it's doing. I don't know, is anybody in here a data scientist where they can give us definitions?
It's kind of the number of times that you're actually ciphering all the entirety of the data. So that, if you're thinking about it, it's, if you go back to even